Hello there. Hello, and welcome to this live webcast on planning for Industry 4.0. It is a chance really for us to take a look at some of the challenges around Industry 4.0 and the challenges of cybersecurity in what can only be described as a hyper-connected world. You know, I have to say first off, it's really great to see such a fantastic turnout for what has to be one of the most hotly debated topics at the moment. 4.0 promises really to deliver a revolution in how we manufacture and manage the critical infrastructural services upon which we all depend. In fact, as you may know, it's, according to Gartner, a developing trend with a value of something around $60 billion this year. It's certainly also the subject of a lot of hype and a lot of PowerPoints. So today, what we wanted to do was really try to get to grips with the reality of the subject. Take a look at what critical infrastructure can do to take advantage of 4.0, what the potential benefits are, and crucially, how to plan to take advantage of them. Okay, so my name is John Stevenson from Deep Secure, and today we're fortunate to be joined by Aaron Mulgrew, Senior Solutions Architect at Deep Secure. Aaron's expertise in this field is invaluable. Indeed, he's someone who's well versed in helping design cybersecurity solutions for some of the most security conscious organizations in the world. So Aaron's here today to talk us through some of the technology and show us some of that technology. Of course, we'd really like you to get involved with this session, so please use the question facility on your webinar control panel. Submit your questions for Aaron or for myself, either as we go along or at the end, and we'll be sure to answer them. In fact, what we'll probably do is compile a compendium of all the questions asked and the answers to them and circulate them at the end of this webinar. Okay, so to start the session, we're going to take a look at some of the key characteristics of Industry 4.0 and how it's centered on the idea that the connectivity of devices across entire ecosystems is really the thing that's going to drive efficiency and maximize value. We'll take a look at the business challenges, so how to move to 4.0, how to do it in a way that defends systems from attack and ensures availability and integrity. And then we'll have, once we've had a look at some of the technology you can use to underpin that move, we'll also have a demonstration. We're going to take a look at a couple of use cases, in fact. Aaron, what are you going to take us through?
Thanks, John. Today, I'll be taking us through how you can safely import feeds from an IT system into an OT system, such as SCADA. I'll also be showing how to safely exfiltrate syslog traffic to Azure native services, such as Log Analytics and Azure Sentinel.
Fantastic, and that second use case, that absorption of OT data into the cloud is one of the sort of guiding principles, if you like, of 4.0. So that's going to be really interesting for us to see. And of course, we'll close with your questions, some next actions, pointers to where you can access more information and resources. Now, if you spend even a few minutes online, you'll probably conclude that the Industry 4.0 is a term that's subject to multiple definitions. Wikipedia, for example, it summarizes 4.0 as the ongoing automation of traditional manufacturing and industrial practices using modern, smart technology. Okay, that's fine, but let's refine it a little further and say that 4.0 is the digital transformation of manufacturing and production and the related industries and value creation processes contained therein. And that's the interesting part, the value creation, because of course it's a topic that sparked intense interest. That's a reason for that, of course, is that as organizations look to 4.0 to help increase productivity, become more agile, accelerate innovation, inevitably drive down cost and increase profits. And in order to do that, they've got to deal with one of the biggest challenges facing any organization in pursuit of these goals. And that's how best to defend against cyber attack while still maintaining system availability and integrity. And that's what we're going to look at next. Historically, of course, with strictly segregated operational technology, or OT, and informational technology, or IT networks, cybersecurity was both simple but also rigid, inflexible, and tended to introduce a great deal of latency into business processes. For a start, systems weren't connected to the internet. Within the business, ERP and MRP systems communicated with each other, while data from the OT network at each plant or site fed production data into the business via data diodes, unidirectional communication links that allowed the data to flow in one direction only. As a consequence, logging and archiving data was available, of course. It was available internally at least, but was necessarily fragmented, and the inflexibility of the model created latency in business processes such as scheduling and maintenance. Now, today, the same fundamental architecture exists, but the advent of the industrial Internet of Things, so interconnected sensors, instruments, and other devices, has created an explosion in interfaces between the OT and the IT environments, with a consequent increase in exposure to cyber attack. What's new, what's different, what's changing with Industry 4.0? Well, the premise is that the cloud takes center stage, with ERP systems, MRP systems, equipment manufacturers, business partners, all benefiting from site data that delivers a 360 view of the operational network and its assets in real time. Of course, that's a highly seductive view of the world, but the truth is there are no real blueprints on how to get there today. And by that I mean, at least in the commercial world, there are no reference benchmarks on how to implement secure data transfer, for example, between systems of different sensitivity in a way that supports that cloud-centric 4.0 model, that model of data on demand to improve decision-making in the cloud for all stakeholders. So how do we proceed? Well, making the technical journey to 4.0 is really a case of thinking in terms of evolution and not revolution. Starting with securing the data transfer, for example, between OT and IT, both for something like seam logging, so monitoring performance and security of the OT network, and for OT data extraction, so grabbing data, something that's needed, for example, to support predictive maintenance of OT equipment. And then moving on this evolutionary journey, we can look to IT to OT communication. So, for example, how precisely we're going to secure scheduling feeds and patch management, so we can ensure OT systems are kept up to date with the latest OS applications and patches. Then we are able to take a look at enabling the transfer between OT and the cloud. So, for example, handling seam logging, but this time making it possible to do so in cloud-based monitoring environments like the one Aaron's going to show you later. Sharing OT data, delivering that 360 view of plant and assets to stakeholders wherever they are. Of course, this evolutionary plan requires us to acknowledge what a very hostile cybersecurity landscape we are dealing with. Cybersecurity on critical infrastructure and attacks on critical infrastructure are growing in frequency and potential severity. So whether it's Stuxnet attacking systems using a combination of zero-day attacks, or Triton targeting industrial safety technology from Schneider Electric, or Shamoon maybe targeting oil, gas and the energy sectors across the Middle East and beyond. Defending against cyber attacks is a persistent challenge. Now, from a security perspective, remember our definition. If you could share data across physically, logically, and administratively separated networks in a reliable and secure and interoperable manner, the goal of 4.0, you need enabling technologies that ensure availability, integrity, and confidentiality. So you can reliably extract data from OT plants and assets. So you can do it in a way that's scalable. You need security that can support the transfer of data over modern bidirectional protocols. You need to do so in a way that absolutely ensures the integrity and confidentiality of the data. Okay, we're going to take a look now at an enabling technology for this kind of 4.0 initiative. We're going to take a look at the Threat Removal Plus data diode. That's a technology that's been designed for the challenges of 4.0. As a data diode, it of course enforces unidirectional traffic flows. It's capable of supporting multiple use cases through the same unit. Indeed, you can see here 2 independent boards, each governing flow. So you can think of it as 2 intelligent diodes in the one unit. The unique factor of this technology is it uses hardware logic, so FPGAs, to verify the data passing through, making it impossible for an attacker to remotely compromise the verification process. And again, uniquely, to combat the rise and the risk of attacks contained in content, this unit uses something called Zero Trust CDR, something that makes it uniquely relevant to the world of Industry 4.0. It's Zero Trust because it's a technology that transforms all the data passing through without trying to detect whether it contains a threat. What does that mean? So for IT files, it means the data crossing through the diode is always malware free. And for OT files, it means that data is constrained. It's constrained to predefined schemas, predefined definitions. So the data itself can't be used as a vector for attack. The Threat Removal Plus data diode is designed to support secure data transfer for Industry 4.0. In terms of the value of that, think of this as a diode plus. Think of this unit as a diode plus. By that I mean it offers what's good about a data diode, so assured one-way data flows enforced at a hardware level, with the industry-leading approach to preventing malware, one that ensures malware concealed in content that simply can't pass. And in terms of ease of use and deployment, this is technology designed for 21st century application needs. So it's got a low total cost of ownership. It's like having 2 one-way diodes, but with none of the traditional problems that you have there in terms of managing data loss, lost packets, being uncertain whether data that's been sent has actually arrived, having to deal with unidirectional protocols when in fact you have applications that use bidirectional protocols. You've got none of those problems. You've got essentially an environment that's designed for the job with high availability and resilience built into the architecture. And of course, the unique way that Zero Trust CDR works means it's delivering you high assurance cybersecurity, providing assured one-way flows, verifying the business information in hardware to prevent malware, and ultimately, of course, that means it's a business enabler for initiatives such as this. The Threat Removal Data Diode Plus solves the problem of safely allowing support for 2 independent one-way flows in a single device, and in doing so, it doesn't isolate your business from your operational systems. Okay, let's see the technology in action right now. I'm going to pass you over to Aaron, who's going to take you through a couple of the use cases we've just been discussing, so you can see how it can be applied.
Thanks, John.
One second, Aaron.
Yeah, no problem.
Okay.
Perfect. Thank you very much. So in this demonstration, I'll be showing how you can safely import energy scheduling feeds into a SCADA system, and how to safely exfiltrate syslog traffic to Azure native services such as Log Analytics and Azure Sentinel. So if I go to the next slide, we'll be able to see the first use case architecture. So here we can see the first use case architecture for safely importing data scheduling feeds. So this architecture consists of an IT side script, which firstly pulls new data from an IT side SQL database, hosts that data across a threat removal plus diode, and finally receives that data on the OT network. This is a typical OT ingestion use case with a modern twist by using JSON over HTTP on the domain gap. Finally, it puts the data into the control center database for the SCADA system to kick into full effect. So let's see that in action. So what I'm going to do here is I'm actually going to browse across to a couple of virtual machines that I currently have running. This is an IT side virtual machine. And then we also have an OT side virtual machine. So this OT side virtual machine is currently empty. So if I hit this button here that says check for new data, we can currently see there is no data in the OT side database. So what we're going to do is we're actually going to add or submit a new energy production amount. So we're going to select a plant. So we'll select the plant Hinkley Point, and we'll select a date for when we want the new energy production required from that plant. So we'll hit the date, the 18th of November, and we'll say at 8 AM, that plant in particular requires 68% power. Now, when I hit submit on this, it will be added to an IT side database. A script will automatically go and pull that new data from the IT side database, post it across the threat removal plus diode, with schema checking in hardware, as John has mentioned. And then finally, that data will be received on the high side through various integrity means that we know that it really has received that data that is expecting. And then finally, put that into the high side SQL database, so on the OT network. So when I hit submit, we can see that successfully added it to the low side database. And if I scroll across to the high side database, we can see there's a new HTTP post that has been received on the OT network. So when I hit check for new data, we'll see there is a brand new record has appeared on the OT side database. We can see that at 8 AM on the 18th of November, 68% power is required on the Hinkley Point plant. So we can see from that demonstration that is super easy, super simple to set up, but gives you that real high assurance that you need when you're sending data from an IT environment to an OT environment. So what we're going to do now is we're actually going to browse back to the slides, and what we're going to look at now is the second use case. So in this architecture, a script is listening to syslog traffic within the OT instance. This script is posting the syslog traffic via IX directly out to an Azure native service, Log Analytics. We can then use Azure Sentinel to look at the Log Analytics logs for cloud native log analysis and security alerting. So this is a super important use case where as we move towards Industry 4.0, we want to move wherever possible monitoring to the cloud and make sure that those security alerts really do make it to the cloud. So you need a highly available solution that will really ensure the data integrity of the data that is going to the cloud, especially when you're talking things like security alerts. So going back to the same environment that we had before, we have the OT side instance. And what we actually have is we have a script that is currently plugged into the OT side virtual machine, and that is listening to syslog traffic. And when it receives a new RDP event, so when somebody connects in over RDP, then what will happen is it will go pull that data, go send it across threat removal plus diode, and then that will go directly off to the cloud from there. And then we'll be able to switch and show you the alerts in Azure. So what I'm going to do is I'm going to click close on this tab. I'm going to go to my remote desktop manager, and I'm going to just reconnect to that OT client. So as it's reconnecting, you'll see there's a whole host of new events have been triggered, and the script that's listening to those syslog events or the Windows event log events has picked up the new events, the RDP events, has posted them directly off to the cloud. So what we can do now is we can actually switch back and go to our Azure environment. And if we go run a new query against the logs and we sort by time generated, you'll see there's a whole host of new logs have appeared. And inside one of these logs is actually the event data itself. So we can see that an administrator has logged on over RDP. And this has triggered an Azure Sentinel alert. So we've got Azure Sentinel currently running against these logs here, all exposed safely, exfiltrated safely from the OT environment. And what I can do is I can actually show you the Azure incident that has spawned. So we can see there is a brand new rule that's triggered, and we can see that somebody has logged in remotely via RDP, and that has triggered the rule here that we can see here. So what I'm going to do now is I'm going to stop sharing my screen and pass back to you, John.
Thank you, Aaron. And that latter use case is a classic sort of 4.0 requirement, yeah?
Yeah, that's correct. So with Industry 4.0, I think one of the kind of key things from my perspective is you really need to be able to try and exploit the full capabilities of the cloud where possible. And even these days, technologies such as the threat removal plus data diode it enables that ability to do so, where previously it may not have been acceptable for high availability purposes or even security purposes to safely exfiltrate that data to the cloud.
Okay, so this is an evolutionary step forward in terms of both security and kind of availability, if you like, of certainty of getting the data through. Yes,
that's correct.
Fantastic, excellent stuff. Okay, so let's just sort of summarize, I think, now our session, if I may. You know, moving to Industry 4.0, it's all about adopting that cloud-centric computing model to deliver OT data, to deliver the state of plant and assets on demand to stakeholders wherever they are. As we've been discussing, one of the big obstacles to achieving this is establishing a secure, reliable infrastructure, one that's capable of delivering that availability, integrity and confidentiality for the data being carried to the cloud. What we've been looking at now in the case of this particular diode is an enabling technology to help us achieve that goal. Of course, it enforces a unidirectional flow on data, but it's operating at near line speed in doing that, with error checking and correction built in to ensure that transfers both fast and reliable. It was designed from the outset to support the kind of bidirectional protocols, such as web application protocols like HTTPS and JSON, the things that you need in order to conduct modern cloud-centric computing and build modern cloud-centric computing applications. This is a multi-purpose diode, so it's one capable of handling both IT to OT and OT to IT use cases. It's designed for non-stop operation, so It's got the high availability and the failover built into the very fabric of the design. And as a threat removal diode, it's capable of verifying the data that it carries is safe. For example, by constraining it to predefined schemas. And because that verification is performed in hardware using FPGAs, it can't be remotely compromised by an attacker. And what that gives is a massively reduced attack surface. Okay, I can see we've got a couple of questions on the question board here. I'm just going to take a couple, I think, and then we'll handle all your questions if necessary offline and send answers to them after this event. But I can see a couple here already. So I have a question from Kareem. Kareem's asking. He'd like to know a little bit about how you can actually make a high availability solution using this technology. Aaron, could I ask you to say a word or two about that?
Yeah, sure. So the Deep Secure solution can be made highly available very easily compared to legacy technology such as traditional diodes. And this is because we have native support for modern protocols such as HTTPS compared to something like UDP for an optical diode, which means that you can actually verify the responses back from the OT environment or from the high side, from the secure environment, to ensure that the data really has got there. And that means that you're able to fail over very easily and actually ensure that the system overall is highly available, and you're able to do that super easily.
Okay. So this is really back to the whole bit about being built for modern applications and thus able to handle things like applications that want a response to a request, that kind of thing.
Yeah, that's exactly it.
Fantastic. Okay, Kareem, hope that answers your question. Another question I just wanted to touch on here from Emma. Emma would like to know how the environment is managed, how you manage the diode. Aaron, could you give us a couple of words on that?
Yeah, sure. That's a very good question. So the threat removal plus diode is a very low touch diode, and once it's deployed, it doesn't need to be fed and watered. You configure it, you deploy it, and then you leave it for a period of time. There is no security updates needed to the appliance itself. It sits there and does its job in the background. And if administrators would like to go in and actually manage the appliance itself, then it's very easy and can be configured for a simple web-based GUI.
Okay, good stuff. Excellent. Thank you. So low touch and a simple GUI based. Fantastic. Thank you very much indeed. Right. I think for more information on this topic, I should point out as we come to a close here that there's an ebook handout attached with this webinar. So in there, you'll find some good advice and information on ways you can build secure communication into your Industry 4.0 initiatives. Needless to say, if you want to discuss any aspect of the issues or technologies we've been going through today, please don't hesitate to get in touch. Use the email address or phone number on the screen right now, and we'd be delighted to get involved and open a dialogue with you. It remains for me to say thank you for attending this live webcast. Enjoy the rest of your day, and we look forward to speaking with you again soon. Bye-bye now.